Recording in progress.
Right. So we want to find dv and dt. Now we have everything we need because we know dv and dh is pi r squared. We just found out that. Oh, that's a 2. Anyways. And then we were actually given the dh and dt, and that's 2. So my expression for dv and dt would be 2 pi r squared. But do not forget the substitution. They asked me for this dv and dt when the value of r is 15. So you cannot forget that substitution, right? Because they specifically asked me for dv and dt when r is 15. So do not forget your substitution. All right. Let me use the orange. So when r, so like you can write a statement to it. When r is equal to 15 centimeters, then dv on dt has to be equal to 15. Oh, what am I? That's funny. Anyways, 2 pi, replace the r with 15 squared. 15 squared is 225, and then 225 by 2 is 450. 450. Pi, don't forget your units, cm³ per second. Everybody good? Can I clear this now?
Yes, ma'am.
Nice. Okay, last question. Let me just, actually, no, do this one by yourself. You, like I was doing before, read the question and you can underline what you need to note, you know? Some oil is spilt onto a level, what? Anyways, whatever that says, and spreads out in a shape of a circle. The radius r centimeters is increasing at a rate of 0.5 centimeters per second. At what rate is the area of the circle increasing when the radius is 5 centimeters? So let's say we're not specifically doing, this is just hypothetically speaking, right? Let's just say we were not specifically doing rates, the topic rates. And you are in your exam, or maybe like a mock exam, something like that, and you come across this question. Well, how exactly would you know that this is a rates question they're talking about? Well, you see this right here, autorater. That's all you need to know. To know that this is a rates question that you're dealing with. Once it's a rates question, these are the 3 things you need to make sure you know. Whenever they say rate of whatever, we know that's with respect to time. So they just mentioned rate, right? That's with respect to time. So you put the dt in the denominator. But what quantity goes in the numerator? Well, let's read the question. The radius r centimeters is increasing at a rate of 0.5 centimeters per second. R is increasing at a rate. So r would go here. This is dr dt, which is 0.5 centimeters per second. And the units make sense because if r is measured in centimeters, so centimeters is the numerator and seconds is the denominator, then I would get this unit, centimeters per second, right? So it makes sense. Second step, you are manipulating the chain rule to find what they want. What do they want? At what rate is the area of the circle increasing? Rate, area, rate, and area. Rate meaning it's on dt, and what quantity are they investigating here? It's area. So that would be dA on dt. That is what we are trying to find. So my dy and dx would be replaced by dA on dt. Let's go to the black screen. So the first thing I know, dr on dt is 0.5 centimeters per second. Next thing, we said we're manipulating the chain rule to get what we want. So that's dy on dx is equal to dy on du multiplied by du on dx. We already figured out that what they're asking me for is dA on dt. So now we need to find an expression that I can use to find dA. Oh my. To find dA on dt. Right. So I know the dA comes on top here. We need to find out what goes down here. And I know that they gave me dr and dt. So that comes over here. So what does that mean? What do I need to put down here so that it cancels with this to give me the dA on dt? What do I need to put down here? dr. Right. Okay, so I have this. They told me that, but the problem is I need to find this. That's the only way I'll be able to get dA on dt, right? So the third thing I told you to look out for when doing rates questions, what do they want you to find? Is it volume or is it area? In this case, it's area, right? Area of what shape? The shape is a circle. So therefore, I'm using the area of a circle. So A is equal to, notice in this case, they did not tell you, did they? No, it did not tell you the formula for the area of a circle, which means you are required to know it beforehand, right? So make note of these things, right? Pi r squared. So dA, let me use a different color. That white is just too much. dA on dr. So the only variable I am allowed to manipulate is this r. I am not touching that pi. It's the r. So this would become, you bring the 2 across here, so it becomes 2 pi r, and then we know we subtract 1 from the power, so 2 minus 1 is 1. It's understood that the 1 is there, so I could just leave 2 pi r. But we're not finished, because we still need to find dA on dt. So what do? dA on dt would be dA on dr, which I just found out is 2 pi r, multiplied by dr and dt. And they gave me that it's 0.5. Simplifying this. Oops. Anyways, simplifying this, I would actually get pi r. But we don't stop here. Why? Because they specifically said when r, which is the radius, is equal to 5. So my final step would be to substitute that into this expression right here. So when r is equal to 5, then dA on dt is actually going to be 5 pi but don't forget your units. This is area, so it's centimeters squared per second. Everybody good with this? Yes, no? How much mass would be lost if the units are wrong or omitted? Well, that actually depends on the marking schema, but it is possible for you to lose 1 mark for it. Because on the mark scheme, it might be like 1 mark for this value here, and then another mark for the units. So if you get the units wrong, well, obviously you would lose that mark for the units, right? The unit is my problem. This is area, so it's centimeters squared, and this is time, so it's seconds. So centimeters squared per second. You think so? You understand so?